previously we considered this function generator when we were describing what a function was. And we said that a number would go in, and then the function would operate on it and chew it up and then send another number out. This number would go in and then send a number out. This number would go in and then send a number out. And so we said that the set of all inputs was called the domain, and that the set of all outputs was called the range, right? The things that got spit out. So the things that went in to get chewed, to get chewed on were called the domain, and the things that came out as a result were called the range, right? So now we want to find a function, right? A black box that will take this range and send them back to the domain, right? So we want -1 to go in and then come back to -2. And we want 3 to go in and come back to 0. And then we want 7 to go in and to come back to 2, right? So we need to find what this function is, this new function generator. And this new function generator will be called this will be the inverse function, because it just returns the range back to the domain, right? This is the terminology that people have decided to call it. They've decided to call this thing the inverse function. So I'm going to step off to the side here and derive this. So the way you do this, remember that this is y, right? These are all the output values, which we call y. And then the function itself is 2x plus 3. So y was equal to 2x plus 3, like this, right? The way we do this is we take the y and the x value and we switch them. So that we have x is equal to 2y plus 3. But this new y here, right, we solve for y, and then that will be the inverse function. So we don't want to call it y. Let's call it y inverse. So you switch the two and then put this little -1 on it to make sure that your professor knows that you know what you're doing. So subtract 3 from this side because we want to isolate y inverse. Subtract 3 from the other side. So we have x minus 3 equals 2 times y inverse, because these two guys cancel, right? Then we divide by 2. And this cancels with this, and I'm going to flip it around because that's the way we're used to seeing it. And so y inverse is equal to x minus 3 over 2, right? So this new inverse function should take the range and send it back to the domain, right? So this becomes, we can think of this as becoming these are the new inputs now, right? And then we want the outputs to be these over here, right? So let's send -1 in, and this thing is going to take it, right? It's going to subtract 3 from it, and then divide it by 2. So -1 goes right here. -1 minus 3 is -4, divided by 2 is -2, right? 3 goes in, so we have 3 minus 3 is 0. 0 divided by 2 is 0. So look, 0 comes out. 7 goes in. 7 minus 3 is 4, positive 4. Divided by 2 is positive 2. And look, 2 comes out. So this is the method that you would go about to find the inverse function, and there will be some examples to follow, right? Now, one property of the inverse function is that f inverse of f of x must be equal to x, right? Because whenever you put these function values into it, right? When these function values come into it, the original x values have to show back up, right? Like this says here. So this is a check that we can do, right? So remember how we do composite functions. We write f of x on top, right? Let's write f of x first. And f of x was 2x plus 3. And then f inverse of x was equal to x minus 3 over 2. Right? So we take this guy and we stick him right there where that x is. And then that should be equal to x. So this will be f inverse of f of x. F inverse of f of x. Okay, so x minus 3 over 2, but x is becoming all this stuff. So this is 2x plus 3 minus 3, and all that's divided by 2. Right? We can drop the parentheses because we're just subtracting this number from this. We're not multiplying or anything like that. So then this negative 3 is going to cancel, this positive 3 is going to cancel with this negative 3, and we'll have 2x over 2, and those 2's are canceling, and this is equal to x, as it should. So this is the condition, right, that you can check to make sure that you got the right function, right, that you got the right inverse function. Okay, so this is an introduction to inverse functions. I'm going to step out of the way and give you a clear screenshot. Try it for yourself.